So good morning students, welcome back. Today we will discuss some objective question related to chapter current electricity. Okay, so let's start based on drift velocity and the resistance and that type question. So let's start the question. Look at students, the first question. The length of a given cylindrical wire is increased by 100%. Okay, due to consequent decrease in diameter. Okay, the change in the resistance of the wire will be, we are given four options, 200%, 100%, 50% and 300%. So look students, first of all I am going to explain the language of this question. Actually we are given a wire, its initial length is L, suppose AB is a wire, okay, its length increases by 100% means what? Okay, it become 2L, so L2 will be what? 2L. 100% increase means what? L plus L, it become 2L. Okay, that is the important point. Let initial area of cross section A and final area of cross section that we have to find, because on changing length, diameter or area of cross section will change. Okay, the wire become thin, so that will change the diameter. Now students see, let initial resistance is R. Okay, and we have to find R2, that is final resistance. On account of that we will calculate the change in resistance. For finding change in resistance, what we require? Initial resistance and final. Initial we will assume as R, so we have to find final resistance. Okay, so look students, when we stretches the wire, okay, when we make its length double, when we increase its length 100%, in that condition volume will not change. Initial volume will always equals to final volume. And you know formula of volume, area into length, area of cross section into length. A1 we are having as A, L1 we are having as L initial length, okay, and A2 that we have to find, and L2 we are having as 2L. Look students, L2L cancel out, okay, and A2 is what? A2 we have to find, okay, L2L cancel out, so that's give A2 as, look at students, what should be A2? It's L2L cancel out, it's A by 2. It means what we found, on making length double 100%, its area of cross section become half. Okay, now students we'll apply the formula R equals to rho L upon A. That is the relation between resistance and length and area of cross section. You know, rho is called resistivity, R is called specific resistance. L is the length of wire, A is area of cross section, R is resistance. That is dependence of resistance on length and area of cross section. So for first condition, R1 equals to rho L1 by A1, and for second condition, when we increase the length, this is the first condition, this equation, and I'm going to make another equation for second condition. When we make its length twice, rho L2 by A2. Okay students, now students look, just remember A2 is what? A by 2. Suppose this is first equation, this is second. Now first divide by second. R1 by R2, rho L1 by A1, okay, and rho L2 by A2. Now students, I am going to remove this portion. Look, rho to rho cancel out. R1 is R, R2 that we have to find. Rho to rho cancel out, okay, L1 is L and A1 is A. A2 is A by 2 and L2 is 2L. A2 will cancel out, L2 will cancel out. 2 2s are 4. Okay, you can note this. I'm going to remove this portion. So what we'll get students finally? Finally we'll get here R2 as 2 2s are 4. 4R. That is the first important relation. Actually, initial resistance we assume as R, R1 as R, and final we got as 4R. So now we can find the change in resistance. How can we find change in? Percentage change in resistance. That is R2 minus R1 upon R1 into 100%. final minus initial upon initial into 100%. R2 is what? 4R. Final resistance that we found. Okay, R1 is initial resistance that we found as, that we assume as R upon R into 100%. 4R minus R, 3R. R2 are cancelled out. 3 into 100, it will give 300%. So when we make the length, when we increase length 100%, either we can say when we make the length twice, its change in resistance will become 300%. Okay, so this is the correct option. D is the correct option. Okay, students. So now, students, question second. If a wire is stretched to make it 0.1% longer, okay, its resistance will be, we are given the option, increase by 0.05%, increase by 0.2%, decrease by 0.2%, and decrease by 0.05%. Okay, students. If a wire is stretched to make it 0.1% long, okay, I'm going to solve this question. Look at, students, we know what is the relation between resistance and length. R equals to rho L by A. Resistance is directly proportional to length of the wire and inversely proportional to its area of cross section. And rho is called specific resistance or resistivity. Okay. What we do, students, we will multiply and divide by L. We multiply with L and we divide by L. Why we did so? Because area into length, rho L into L, L square. Area into length become volume. Okay, look, students. Rho is resistivity, that remains constant. Volume of wire, when we stretch the wire, its length increases, its area of cross section will change, but its volume will never change. So why we did so? In order to gain this rho, that is a constant, in order to make volume, because volume is a constant. Now rho is already constant and we made volume, area into length become volume. Okay, that's how we multiply and divide by, because volume will be constant. So whenever we remove this constants, okay, constant terms, equal will change in proportional sign and there comes L square. It means we are getting that resistance is directly proportional to square of the length in case of stretching the wire. Okay, on account of that, that is an important formula. On account of that, okay, we'll solve. Now we'll convert into relative error. Okay, that is a topic in 11th class, error topic. So we'll convert into relative form. So we can write like this: delta R by R into 100%. That is the percentage form. Okay, and this is the M, that power always comes in multiplication. It may be plus minus 2 delta L by L into 100%. Delta L by L, that is relative error, and when we multiply with 100%, it will convert into a percentage form. That is a topic, error related to 11th class physics, first chapter. Okay, dimension like. Now, students, what is the meaning of this mathematical term? The meaning of this term, percentage change in R. Percentage, okay, R is proportional to L square, directly proportional. It means on increasing length, resistance will also increase. So look at, students, 2 as it is. Okay, and what is the meaning of this term? Delta L by L into 100%. The mathematical terms of this, it means that percentage change in length, and how much we are changing? 0.1%. It means delta L by L into 100% means what? 0.1%. When we multiply, what we get, students? 0.2%. We'll get 0.2%. So this is 0.2%. Increase by 0.2%. B is the correct option. Why? Because resistance is directly proportional to the square of the length in the case of stretching the wire. So proportional means what? On increasing one factor, other factor will also increase. So when we make the length, when we stretch the length 0.1%, when we make it 0.1%, resistance becomes 0.2%. So increase by 0.2%, B is the correct option. Understood, students? So now, students, question number 3. Suppose the drift velocity Vd in a material changes with the applied electric field vector E as by this relation. Okay, Vd proportional to root E, where Vd is the drift velocity. What is drift velocity? The average speed of electron from negative terminus to positive under the influence of external electric field is called drift velocity, and E is electric field. This relation we are given. Then V dash I graph for a wire made of such a material is best is given by. So we have to make graph between V and I, and we are given the 4 option. Okay, for such relation. So how can you find? Let's start, students. VD proportional root E that we are given. Okay. We know the relation E equals to minus dV by dr. Either we can write as V by L. On taking modulus, we can write V by L, where V is potential, L is the length. Okay, distance. That is the relation between electric field and potential. So electric field is directly proportional to potential. So we can write as VD proportional to root V. Because E is proportional to V, potential. Electric field is proportional, directly proportional to potential. So E replaced by V. Okay. Now students, one more thing we did. What is the relation between current and drift velocity? I equals to V now. V D E N A. इस तरह we can इस तरह हम इसको याद रख सकते हैं. We can learn about this V now. V D E N A. V D is drift velocity. E charge of electron and number of electrons in per unit volume, and A is the area of cross section. Look at current. On account of that, current is directly proportional to drift velocity. Okay, so now we have to consider on these two relations, drift velocity proportional to root V and drift velocity proportional to I. So from, suppose this is first and this is second, so from first and second we can write as root V proportional to I. Okay, and when we take square both the side, it become V square proportional to R. V square proportional to I. Look students, this type of equation should be of parabola. So graph between V and I should be a parabolic and V square. So it should be along V axis, okay, potential axis. So this is the graph, we are given a straight line like this, okay. This is the parabola, okay, and along the potential axis, V axis. So which one is the correct option? The graph should be parabolic, V and I, this will be the graph. So for V square proportional I, for such relation, this will be the right option, parabolic along the potential axis. So option B is the correct. Question number 4. In the given circuit, the galvanometer, okay, this is the galvanometer, G shows zero deflection, okay. The galvanometer is showing zero deflection, okay. If the batteries A and B, that is A battery and that is B battery, marked have negligible internal resistance, then the value of resistor R will be, okay. We are given two circuits A and B. This resistor R that we have to find, okay. And one important condition are given that galvanometer does not show any deflection. What is the meaning of that? We know, students, current always flows from higher potential to lower until it does not become equal. Galvanometer does not show any deflection. It means potential at both the terminals will be same. If battery A having 2 volt, this R also having 2 volt. Where two terminals having equal potential, in that condition current will not flow in that circuit. That's why galvanometer is showing zero deflection. That is the key word. Understood, students? Okay. Now I'm going to solve for this first circuit. What should be current? This is the first circuit. Current as V by R, Ohm's law. Potential is 2 volt and resistance is R. Equation first. Now I'm going to solve current for this second circuit. For circuit B, that is A battery and that is B battery. So what should be the current for second? V. This time we are having 12 volt in this portion, and when the current flows, equal current flows in both the resistance. So both are in 500 and R are in series. So as a total resistance will take 500 plus R. Equation second. Both are showing to current. Compare first and second. 2 by R will equals to 12 by 500 plus R. Now should cross multiply. R into 2, that become 2R. That become 12R. And okay. Look students, R into 2, 2R. And 502, that become 1000. Okay. Now R into 12, 12R. Transfer 2R at their side, 12R minus R, 1000 equals to 10R. 0 to 0 cancel out, so we'll get as 100 ohm. So what should be the value of this resistor? That should be 100 ohm. Option B is the correct. Just remember, students, one important keyword in this question, that if calorimeter does not show any deflection, that is important point. It means these two wire having same potential, because current always flows from higher potential to lower, and when the two terminals having same potential, current will not flow. That's why that resistor having also potential the 2 volt. And we found current for this first circuit, and we found current for second circuit. Compare, we got the resistance. Understood? So now, students, question number 5th. We are given 10 identical cells. Okay, each of EMF as E, capital E, and internal resistance small r are connected in series. Okay, first of all, to form a closed circuit, an ideal voltmeter connected across 3 cells, not with all cells, connected with 3 cells will read. So actually we are given 10 cells, they are connected in series. Okay, like plus minus till 10 cells. Okay, having internal resistance small r and having EMF E. And look, students, out of 10 cells we are connecting voltmeter. Okay, we are connecting voltmeter with the 3 cells. So what will be the reading of that voltmeter? That we have to find. Okay, look, students, how can you find? Generally, we'll find first of all current of that circuit. As current flow through that circuit, I equals to, we know, that is total EMF by total resistance. What is total EMF? Total EMF of 10 cells. They are connected in series. So it should be 10 times of E. E1 plus E2 plus E3, so 10 times of E. And as they are connected in series, so total internal resistance will be 10R. So 10 to 10 cancel out. So how much current will flow in that circuit? E by R. Okay, look. Now we have to find potential difference across these voltmeter. So what is the formula of potential difference? V equals to IR. I. And as R, what will take, students? Current we are given as, we found as E by R. And as a resistance, the voltmeter connected only with 3 cells. So we'll consider the resistance only of 3 cells. So it will be 3R. As a resistance will take 3R, not 10R. R to R cancel out, 3 into E, 3 times of E. So how much reading is taken by that voltmeter? That is 3. So option A will be correct. 3 is the correct option.